Okay guys, hi, this is Mr. Urrego, and this is part of the review that I have from my Algebra 2 classes. Right now, what we're going to do is we're going to graph a system of inequality, of equations, alright, solve each system by graphing. In particular, I'm going to use 36, okay, so I'm going to do 36 right now. Let's put this on the side. Okay, so 36 is 1 plus x equals y. Second equation is negative 3y equals negative 18x plus 12. I'm sorry about the handwriting, but my stylus broke, so I need one. Alright, so the first thing that I need to do is I need to graph one equation at a time. So I take one, graph it, take the other one, graph it. Okay, the easiest way to graph an equation is in the slope-intercept form, which my first it is in slope-intercept form. The general form for the slope-intercept form is y equals mx plus b. Okay, we're used to having the y on the left side. Okay, we're used to having the y on the left side. Right now it's on the right side. So one thing that I can do is I just can move this to the left side and the 1 plus x to the other side without changing anything, just flipping both sides, which I'm going to do that. So I have y equals, that's from the right, equals, and I'm going to organize that 1 plus x because I want the x first. So it's going to be x plus 1. Just organizing, not changing any signs. So x plus 1. Where from here, your slope is whatever number is with the x, there's nothing there, so you have a 1. Okay, so okay, I'm sorry about that. And the y-intercept is whatever is after that, which is 1. Okay, so let's graph that. Okay, alright, so everything is like kind of the different pattern. Alright, so let's graph that. I'm gonna have my so now I have my my coordinate plane. I'm gonna plot this. When I'm drawing a line or graphing a line in slope-intercept form, the first thing that I do is I plot my y-intercept, which is 1 right now. I'm gonna plot it with blue, so that's gonna be there. Okay, and my slope is 1. Right now, my slope is 1. Remember, slope is rise over run. Slope is rise over run. So I need to make that one a fraction. So it's going to be 1 over 1. So from my y-intercept, I'm going to go rise 1 to the top, 1 to the right. Okay, rise 1, run 1. So my second point is going to be around here. Okay, I have my 2 points. Connect them. That's your first line. Same process with the second line. Okay, your second line is going to be negative 3y equals negative 3y equals negative 18x plus 12. I want to write in the slope-intercept form, so I need to leave the y by itself. Therefore, this number is multiplying the y, so I have to divide by the same number. Negative 3, negative 3, negative 3, everywhere. The first part, negative 3 over negative 3, is positive 1, so I have y equals negative 18 divided by negative 3 is going to give you 6x. Positive 12 divided by negative 3 is going to give you negative 4. So from here, your slope is 6, your y-intercept is negative 4. Okay? Make sure you write your slope. You write your slope as a fraction. Okay? Put it as a fraction. Why? Because it's going to be rise over run. First step, y-intercept. The y-intercept is negative 4. So I'm going to go and let me bring that expand a little bit more. Okay. Let's grab this and let's make it more to the left and expand this. So y-intercept is -4. My y-intercept, y is on the y-axis. This is a common mistake. Y equals -4, it should be on the y-axis -4. So it's going to be -4, -1, 2, 3, 4. That's -4. And then your slope is 6 over 1. 6, right 6. So I go 1, 2, 3, 4, 5, 6. And then 1 to the right. Again, whenever you're graphing or you're using your slope, you start at the y-intercept. You start at -4. Then rise is 6, 1, 2, 3, 4, 5, 6, and then run is 1, positive to the right. That's your second point. So as a coincidence is right there. Now I connect my lines. Therefore, the solution of the system is where the two lines intersect. Okay, so now we know for sure that they intersect at this point because that point is part of both. So the coordinates of that point, so my answer of this system is going to be one solution, and the solution are the coordinates of that point, and the coordinates are 1, 2. Okay? Besides having one solution, there's a couple more answers that I can get, which are the special cases. The special cases are 2. Okay, I'm going to explain them briefly just with the graphs. So this is one of the special cases. Let's pretend that I have this system and I need to graph it. Okay, so from each equation I'm going to get the y-intercept and the slope. The y-intercept and the slope. Okay, if you notice, there's one thing that in common in these two equations is that they have the same slope. Okay, when you do systems of equations, when they have the same slope, that means they're parallel lines. We'll find out right now. So let's graph the black one first, which is number 1. The y-intercept is 1. The slope is 2. Make it a fraction. It's 2 over 1, so it's 1 up. So it's going to be 2, 1. Rise over run. 1, 2, and 1 to the right. So that's going to be my second point. Once I have that, I connect the two lines, and that's my first line. The second line is 2x minus 1. So this is B, this is M. -1, -1. Now my spacing over here is not the same, so it's not really too accurate. So the y-intercept is -1, my slope is 2. Again, remember, you make a fraction, 2 over 1. So I go up 2, 1, 2, and 1 to the right. Okay? So my second point should be around here. Unfortunately, right now, my graph is not too accurate because the increments are not the same. So this should be a line something like this. Okay? Which means the lines are parallel lines. If the lines are parallel, then therefore they don't touch. If they don't touch, then there's no solution. The answer of the system is where the two lines intersect. If they don't intersect, then therefore there's no points of intersection, and the answer is no solution. So my answer is no solution. This is one of the special cases. The next special case will be when they have many solutions. Okay, so here we go. We have two equations. We need to graph them. We have a black one and a blue one, and we need to graph them both. The first one is simple. It's ready to use. Okay, so what we're going to do is we're going to plot the y-intercept, which is -2, and then your slope is 1 over 2. Y-intercept is -2, slope is 1 over 2. So the rise over run. First, y-intercept -2. So -2, here we go, in black. That's your y-intercept. Now the rise over run. Rise, run. Sorry for my handwriting. Rise over run is 1 over 2. So from here I go up 1 and 2 to the right, and that's your point. 1 and 2 to the right. So around there's going to be your point. Okay, and I draw my line. Something like that. Your second line is not ready to use because the y has a 2. So because the y has a 2, then we need to divide by 2 to get rid of that 2. By 2 and by 2. So then you're going to have y equals, look at this, 1 over 2x minus 2. Alright? So technically, if you notice, this second equation is the same as the first equation. Alright? They ended up being the same. Therefore, if I plot those points, I'm going to get negative 2 here, and then the slope is 1 over 2, and I'm going to be there, and then when I graph that, technically I'm going to have one line in top of the other one. And if my solutions are all the points that they touch, then therefore many points are touching. So my answer is many solutions. Okay, so many solutions or infinite many solutions, because the two lines are touching. So those are the special cases, guys. Again, one solution because they intersect, and the solution is the coordinates of that point. No solution on the left. We're talking about the left. No solution. The two lines are parallel and they have the same slope. Many solutions. They ended up being the same equation, and when you graph them, is one on top of the other one. Alright? Alright, guys. Thank you.